So resistance is directly proportional to length of the wire, and resistance is inversely proportional to cross-sectional area. So when we combine this will form an equation. Resistance is equals to rho L divided by A. Where R is a resistance, L is a length, A is area, and rho is a resistivity or property, resistance of wire having length of 1 meter and area 1 meter square. So when you compare the two wires, made up of same material, so as we know, like example, if we have two wires, this is wire 1 and this one is wire 2. Area of this wire is A1, length of this wire is L1, and resistance is R1. For the second wire, resistance is R2, its area is A2, and length is L2. So when we use this equation, we have R is equals to rho L by A. So we can say R1 is equals to rho L1 by A1. And for this one, I can say R2 is equals to rho L2 by A2. Because they are made up of same material, so they will have the same resistivity. That's why I use same symbol for the resistivity. So if I find the resistivity here, I can say R1 A1 divided by L1 is equals to rho. And for this equation, I can say R2 A2 over L2 is equals to rho. So whenever two wires are made up of same material, you can compare their resistivity because they will have the same resistivity. Then the formula which you will use to compare their resistance, area and length is R1 A1 over L1 is equals to R2 A2 over L2. The derivation is not important. The final result is important. The equation is important. So whenever you're comparing the two wires which are made up of same material, because sometime in a question they say a wire is having a length of 3 meter, area 5 meter square and resistance 10 ohm. What will be the resistance of a wire if length changes and area changes? So you can work out using this formula. Whenever two wires are made up of same material, the formula will be R1 A1 over L1 equal R2 A2 over L2. I'll give a simple example. If I say this length was 3 meters, area was 1 meter square, and resistance is 100. Then we change the length. We made the length to 4 meter. Cross-sectional area is now 2 meters square. And we want to find the resistance. So if two wires in the question, they should mention, or it should be there, that two wires made up of same material. So if two wires made up of same material, directly you can use this formula R1 A1 over L1 equal R2 A2 over L2. So R1 is the first resistance, A1 is the first area, and L1 is the first length. R2 is the second resistance, like resistance of a second wire. A2 is the area, cross-sectional area, and length is 4. So when I solve this, this is 2. This 2 will be multiplied. So 100 multiplied by 2, that's 200 divided by 3. So 200 divided by 3, 66.66. So 66.67. So when you solve, you will get 66.67 ohms or 66.7, three significant figure. That will be the second resistance. So whenever you are comparing the resistance of two wires, the formula is R1 A1 over L1 equals R2 A2 over L2. Is this clear? So what happened when you have two wires? I'll repeat. If two wires are made up of same material, but they have different lengths in different areas, resistance of this wire is R1, area of this wire is A1, length of this wire is L1. And another wire made up of same material, area is A2 and length is L2. So the formula which you will use the formula R1 A1 over L1 equals R2 A2 over L2. So R is a resistance, A is the area, and L is a length. For first sample, and R2 is a resistance of a second sample of a wire, area is A, second area is A2 and length is L2. So if the values are given, if this was having say 50 ohms, the length of the wire is say 2 meters and cross-sectional area 1 meter square. Then the cross-sectional area is 2 meters square. The length example is 6 meter. We want to find the resistance. So how we can find the resistance? Just substitute the value 50 multiplied area is 1 divided by length is 2 and resistance we don't know. The area is 2 and what is the length? Length is equals to 6. So just solve this. How to solve? This is 2 and this will be 2, 3. This 3 is multiplied. So 50 multiplied by 3, 150 divided by 2, that's equal to 75 ohms. Is it clear? About the this will discuss the rheostat and effect of temperature, but now resistors in series. Like if in a circuit you have two or more resistors connected in series with each other. And if you want to find the total resistance, so to get the total resistance of a series combination, you will simply add. Example, you can see here 2 ohm and 8 ohm resistors are connected in series. So if I want to find the combined resistance, the total resistance of these two, what will happen? The formula to get the total resistance, we will simply add them. So it will be 2 plus 8, which is equals to 10. But if two resistors or two or more resistors are in parallel, then it is 1 over R So if two resistors are connected in parallel, to get the combined resistance, the formula is 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3. Or instead of that, you can use a simple formula that it is product of the two resistance divided by sum. Like multiply the two resistance divided by the sum, so you will get the total resistance when they are connected in parallel.
So 16 divided by 10.
So in this one, like 16, which one? This like in this example, you have 2 ohm and 5 ohm. So what is the combined resistance of this? The total.
7.
They are in parallel. So in parallel, the formula to calculate is a product of the two resistance divided by sum. So the
Yeah, 10
product,
divided by 7.
so 2 multiplied by 5 and divided by sum, which is 2 plus 7. So 2 multiplied by 5 is 10 plus 7. So 10 divided by 7, that's equal to 1.43. So if two resistors are connected, in series, to get the combined resistance, you will simply add them. But if they are connected in parallel, to get the combined resistance, it will be product divided by sum, or you can also use this formula 1 over R is equals to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So why in series we add them and why in parallel it's a division? Actually, it is a simple derivation. How it is derived? Look, for example, again, derivation you don't have to learn, but I will explain how these formulas are formed. Example, you have two resistors which are connected in series. So this one is R1, this one is R2. Okay. If I connect them with a battery, because they are in the series, they are in series, so they will have the same current. If current which is coming from the battery is I, how much current will flow through R1? That will be I. And how much current will flow through R2? That will also be I. And same current will return. Current is the flow of the charges. So in series circuits, the current is same. That we discussed yesterday. What about the voltage? Voltage is energy transferred by the charge. So some of the energy the charge will transfer in R1 and some of the energy the charge will transfer in R2. So we can say, I can say the total voltage V is equals to V1 plus V2. Because what happens, some of the energy used in resistance 1 and some of the energy used in resistance 2. So the total voltage or total energy will be equal to V1 plus V2.
So,
And
sir, this will be the total energy needed.
this is the total energy needed to work this circuit, like total energy or total energy transfer by unit charge. V is the total energy transfer by unit charge. It's a voltage which is work done per unit charge. So sum of the energy, when the charge is coming from the battery, it will have energy V. But some of the energy is used across R1 and some of the energy is used across R2. So the total energy which the charge was having when it entered is equals to V1 plus V2. And you have the formula, as you know, resistance is equals to voltage divided by current. So voltage will be equal to resistance multiplied by current. So what is V? V is the total voltage. So as V is the total voltage, it will be resistance multiplied by current. What is V1? V1 is a voltage across R1. So what is, how we can find, as we know, V is equals to Ri. So what is the resistance here? The resistance here is R1. And how much current is passing? The current is I. Same thing, the voltage V2 is across R2 and how much current is passing, that's also I. So I is common here. So as I is common, I can say it is R1 plus R2 multiplied by I. And this I will cancel with I. So I can say resistance, the total resistance of a circuit in series is equals to R1 plus R2. But again, you don't have to learn this derivation. This is a formula. All these formulas are derived from one base point, but there are certain derivation you have to learn, not all of that. So in this one, the important thing is learning the formula whenever two resistors are connected in series. When you want to find the combined resistance or total resistance, that will be equal to the sum of the individual resistance R1 plus R2 and so on. If there was another resistor here, if there was another resistor in series and that resistance was example 5, so then what is the answer? It will be 2 plus 8 plus 5, which is equals to 15 ohm. So when the resistors are connected in series, what we will observe? We will observe the combined resistance increases. But if they are in parallel, like example, if two resistors are there, and the two resistors are connected in parallel to each other, one is 2 ohm, another one is 8 ohms. And if I want to find the total resistance, so what is the formula to find the combined resistance for two resistors? It is the product of the two resistors divided by the sum. So what is the product? It will be 2 multiplied by 8, which is 16, divided by 2 plus 8, which is equals to 10. So 16 divided by 10 equals to 1.6 ohms. So you can see here, when two resistors are connected in parallel, the combined resistance or total resistance decreases. When they are connected in series, the combined resistance or the total circuit resistance will increase. You can put infinite number of the resistor. Number of resistor you can connect infinite to the circuit. There's no limitation. It's up to you what resistance you want. According to that, you put or arrange it. So if you want to increase the resistance, you connect resistors in series. If you want to decrease the resistance, you connect resistors in parallel. So the derivation is there for parallel also. There's a derivation. A formula is there, drive for parallel as well. But you have to just directly learn the formula. So example,
Sir,
what is the, yes,
in the
continue.
multiplication formula, we can only find the resistance of 2 amperes.
Yeah, that's for 2 only. If there are more
Yeah,
than
only
2,
2.
if there are more than 2, then you have to add the reciprocals. Like it's 1 over R1 plus 1 over R2 plus 1 over
Yeah,
R3,
yes.
and then take an inverse. This is only valid for 2. So why we need resistance? The reason for that, like example, if you're charging your mobile phone and your battery required a small amount of current, but from the supply, from the main source, example 5 ampere is entering. So what happened? This 5 ampere is too much for the battery. Battery cannot resist this too much current. So to make the safe charging inside the mobile circuit, what you have small resistors. So what is the advantage of these resistors? So when these resistors, the current passes through, the current will decrease. So small amount of current will enter the battery. So the battery will not explode because of high current, or it will produce less heating effect. So there are reasons why we use resistors in the circuit to minimize the effect, like it reduces the current so it cannot damage the circuit, because some of the components required a small amount of current for working, but what we are generating electricity, it's high voltage and current. So to minimize or reduce that current, we use these resistors in the circuit. So resistors are having advantages also, that it make it useful for the small scale, like devices which use a small amount of current can work easily. Otherwise, you will not be able to connect a high voltage supply or a high current supply to a device which need a smaller amount of current. Resistor is a main component. It is almost present in all the circuits. It's not only mobile phones. Most of the circuits having resistors. Okay. Now, what is the final answer? What is the effective resistance of this circuit? What is the effective resistance of this circuit? Look, first you check 2 ohm and 8 ohm. 2 ohm and 8 ohm are connected in series. So what is the total of 2 and 8? It will be 10. So means they will act like a 10 ohm resistor. Then there's also another 5 and 5. What will be the effective? Again 10. But when you see this 10 ohm, the effective 10 ohm and 10 ohm, how they are connected? In series or parallel? So they are in parallel. So how to get the total combined? It will be product divided by sum. So product was 100 is 100 and the sum is 20. 100 divided by 20. What you will get? You will get 5 ohm as a effective resistance. Is it clear? This example. Some more examples for better understanding of this resistor. 5 ohms, uh, 10 ohm, and 10 ohms. What is the effective resistance of this circuit? So it's 13.33. Why? Because the first one is product divided by sum. So they are in parallel. So 5 multiplied by 10 divided by 5 plus 10. So it will be 50 divided by 15. So 50 divided by 15 is 13.33. So this total means the effective resistance of this part is 3.33. And this whole component is connected next to a 10 ohm resistor. So 10 plus 13. 3.33, which is equals to, this is 10 ohm. So 3.33 plus 10, which is equals to 13.33. Three ohm, 6 ohm, 5 ohms, 10 ohm. What's the effective resistance of this circuit? Yeah, what's the effective resistance of this circuit? So first you will find, because 3 ohm and 6 ohm are in parallel, so it will be product divided by sum. Yeah. So product divided by sum, what's the effective of 3 and 6? Can 3 multiplied by 6, 18 divided by, so that's equal to 2. So effective is 2. And this one, product divided by sum, so 5 multiplied by 10, 50 divided by 15, that was 3.33. And now these two are in series, one next to other, so the total will be 5.33. So we have DC circuits. DC circuit means a circuit in which the current, direction of the current remains same. A DC circuit can be a series circuit. What is the meaning of series circuit? You can see there's only one way for the charges to flow. So when resistors or other components are connected in series, the current at every point in the circuit is same. Means if 3 ampere is here, how much current at this point? So it will be 3 ampere. And how much current will return? So 3 ampere will return. So the total current which entered the circuit is same as the total current which leaves the circuit. But what happened to voltage?
It will become 6.
So voltage will divide between, we already discussed why the current is same, because current is a flow of the charges in a unit time. So if 5 charges are moving in 1 second, same 5 charges will move through first resistor, same 5 charges will move through the second, and it will return back. Because they don't have any other passage to flow. There only one passage for the charges to flow. So current at any point will be same. But what happened? The voltage will divide. If example, if a current is 1.6 here, so same 1.6 will pass through first resistor, same 1.6 will pass through second resistor. But what about the voltage? So what is the voltage here? How I can find the voltage? I have the formula. Resistance is voltage divided by current. So if I need a
Sir,
volt,
but
yes,
we already have voltage.
we have the total voltage 16, but I don't know what is the voltage at the first 6 ohm resistor and what is the voltage across 4 ohm resistor. So how I can
Yeah.
find the voltage? So we will use the formula V is equals to I, R is equals to V over I. So resistance of this part, this specific part is 6 and the current is 1.6. So resistance is 6 and the current is 1.6. So 6 multiplied by 1.6, what's the answer? 6 into 1.6, that's equal to 9.6. So what does it mean? It means there will be a 9.6 volts here out of 16, 9.6 volt here. And we can also find the voltage across 4 ohm, which is equals to, we have the formula R is equals to V over I. So resistance is equals to 2.4 and the current is same 1.6. So it is multiplied 2.4 multiplied by 1.6. That's equal to 6.4 volts. So you can see here the total voltage was 16, which divided between the two component as 9.6 and 6.4. So in series circuits, when components are connected in series, they will have the same current throughout, but they will have different voltage. And how I can find the total, like example, if a question is calculate the total current. So I need a total current. This formula R is equals to V over I. If I need total current, so it will be total resistance of a circuit divided by total voltage. Or if I need current, R is equals to V over I. But if I need a current is equals to voltage divided by resistance. What is the voltage of the total voltage of the circuit? Because I'm finding the total current. So what is the total voltage here? It's 16. And what is the total resistance of the circuit? As you know that 6 ohm and 4 ohm are connected in series. So if they are connected in series, what is the total resistance? That will be 10 ohm. So we have current is equals to voltage, which is 16, divided by resistance 10. So the total current which is entering the circuit is equals to 1.6 ampere. So how much current will pass? It's 1.6 ampere. So using this, you can identify the total current. And after finding the total current, you can find what is the voltage across each component. Again, using the same formula. Look, this formula R is equals to V over I. If I need total voltage or total resistance or total current, here I will substitute those values. But if I need voltage or resistance or current in the component, then I will use their value. But the formula is same, which is R is equals to V over I. Is it clear the concept of series circuit when components, one component connected next to the other, they will have the same current and we can find the total current by simply total voltage divided by total resistance of the circuit. And what about voltage? Voltage, as we already discussed, we were having the resistance, we know the current, and what we did, we have formula V is equals to IR. So we have the current here 1.6, resistance was 6, so when we multiply, we'll get 9.6. And we have the current 1.6 and resistance 4, so we will get 6.4. So I want you to solve one similar question of DC circuit in series. But in exam, you don't find a direct question. They will like step by step, they ask question. So when you solve one part, that answer you can use for the next part. to solve the whole question. This is a 20-volt supply. This one is 5 ohms. The other one is 10 ohms. The question is calculate total resistance of the circuit. So what is the total resistance of this circuit? Because they are in series, so directly you will add them. So it will be 5 plus 10, which is equals to 15 ohms. Calculate total current in the circuit. And the total current in the circuit is same as current in each resistor. So what is the total current?
1.3.
So we have formula V is equals I is equals to this formula R is resistance is a ratio between voltage and current. So current is equals to voltage divided by resistance. So the total voltage is 20 and the total resistance is 15. So 20 divided by 15. What's the answer?
Sir, what if we need the current between the two resistors, like after the 5
Yeah,
after the
if we
5
need,
ohms?
even if they say what is the current in 5 ohm or what is the current in 10, because they are in series. So in series, the total, what is the total current is which is coming out from the battery is same as current passing through each component.
Yeah.
So it will be same, no difference.
So we'll still take the total.
Still, you will take the
resistor.
total. Yes, you will take the total, and you will get the total resistance.
Okay, sir.
Total current. Now, if you need voltage across 5 ohm, what's the voltage across 5 ohm resistor? So again, the same formula, I will use resistances, but so voltage V is equals to IR.
IR, yeah. 1.3 by 5.
1.3 multiplied by, or 1.33 multiplied by 5. What's the answer? 1.33 multiplied by 5?
6.65.
So that's 6.65 volts across this one. And if I need what I can use a formula, or I can also use an understanding. Look, if the total is 20, if the total voltage is 20 and 6.65 volts drop here, so how much is the voltage here? I will just subtract 20 minus 6.65. I'll get the answer.
13.35.
So it will be 13.35. Or I can use the formula. I will get the same result. Like you can see, the resistance is 10 and the current is 1.3. 1.3 multiplied by 13, 10 multiplied by 1.3, I'll get 13.3. So I'll get the same result. I can do subtraction